Hey guys, in this video we will be going over how to add and subtract rational expressions. So recall that in order to add or subtract fractions, they must have a common denominator. So let's start with adding something like 3 over 8 plus 1 over 6. To add this, first we would need to find the least common denominator, or the least common multiple, of 8 and 6. To find this, we can write out the prime factorization of 8 and 6. And then to find the least common multiple, we need at least 3 factors of 2 for this number to be a multiple of 8. So we include this in our LCM. And then we need at least 1 factor of 2 to be a multiple of 6. And since we already have 3 factors listed, this condition holds. So then we need at least 1 factor of 3 to be a multiple of 6. So we include this in our LCM. Therefore, our LCM, or LCD, will be 2 times 2 times 2 times 3, which is just 24. So to write these fractions as an equivalent fraction with a denominator of 24, we would multiply this fraction by 3 over 3, and this fraction by 4 over 4. So our equivalent expression is 9 over 24 plus 4 over 24. And now that the denominators are the same, we may add by adding the numerators and keeping the common denominator. This gives us 13 over 24. So we can add and subtract more complicated rational expressions in the same way. So to add and subtract rational expressions, we would first factor the denominators. And then if the denominators are not the same, then we find the LCD. And then rewrite each rational expression as an equivalent rational expression with the LCD, and add and subtract the numerators while keeping the denominator in factored form. And then finally, simplify if possible. So let's go over an example. We want to add the following rational expressions. And since the denominators are simply a constant, we can easily determine the LCD, or LCM, of 3 and 6. This is just 6. So to rewrite the first expression as an equivalent rational expression with a denominator of 6, we multiply it by 2 over 2. And now both rational expressions have the same denominator. We can now rewrite this as one rational expression by adding the numerators across while keeping the common denominator. And now we will need to simplify the numerator, so distribute the 2 and then combine like terms. This will then give us 3x plus 15 over 6. And we can actually still simplify this expression. Let's factor the numerator. We can factor out a GCF of 3. And now we can actually reduce the 3 and the 6. And this will give us x plus 5 over 2 as our answer. For the next example, again, since the denominators are not the same, we will need to find the LCD. So we can start by listing the prime factorization of 4x and 10x squared. So in order to be a multiple of 4x, we need at least 2 factors of 2 and 1 factor of x. So we will include this in our LCD. Then, in order to be a multiple of 10x squared, we will need at least 1 factor of 2, which we already have in the LCD, at least 1 factor of 5, which we will need to include, and at least 2 factors of x. And since we already have 1x in the LCD, we will just include 1 more. Therefore, our LCD is 20x squared. So to rewrite the first expression as an equivalent rational expression with a denominator of 20x squared, we will multiply this by 5x over 5x. And to rewrite the second expression as an equivalent rational expression with a denominator of 20x squared, we multiply this by 2 over 2. This will then give us 15x over 20x squared minus 22 over 20x squared. And now we have the same denominator. So we can rewrite this as one rational expression by subtracting the numerators across while keeping the common denominator. And then this is just 15x minus 22 over 20x squared. And it looks like we can't simplify this expression any further since we can't factor the numerator. Therefore, this will be our answer. For the next example, we will first need to write the denominators in factored form. We actually factor this denominator as x plus 3 times x minus 3, since this is a difference of 2 squares. And since these denominators are not the same, we will need to find the LCD. So in order to be a multiple of x squared minus 9, we will need at least one factor of x plus 3 and one factor of x minus 3. So we will include this in the LCD. And in order to be a multiple of x plus 3, we need at least one factor of x plus 3, which we already have in our LCD. Therefore, the LCD is x plus 3 times x minus 3. So the first expression already has this LCD, so we don't have to rewrite this. And to rewrite the second expression as an equivalent rational expression with this LCD, we multiply it by x minus 3 over x minus 3. And now that we have the same denominator, we can write this as one rational expression by adding the numerators across while keeping the common denominator. Simplify the numerator by distributing and combining the like terms. And let's rewrite this numerator in descending order of powers. And the last step is to check if this rational expression can be simplified. We can actually factor the numerator, and then we have a common factor of x plus 3 that we can divide out. So our simplified final answer is x minus 2 over x minus 3. For the next example, again, we will first have to factor the denominators. So the first denominator factors to x plus 7 times x plus 2. And the other denominator factors to x plus 7 times x minus 4. And since the denominators are not the same, we will need to find the LCD. So in order to be a multiple of x squared plus 9x plus 14, we will need at least one factor of x plus 7 and x plus 2. So we will include these in our LCD. And in order to be a multiple of x squared plus 3x minus 28, we will need at least one factor of x plus 7 and x minus 4. So since we already have at least one factor of x plus 7, this condition is held, and we'll just need to include the factor of x minus 4. Therefore, these three factors will be our LCD. So to rewrite the first expression as an equivalent rational expression with this LCD, we multiply by x minus 4 over x minus 4. And to rewrite the second expression as an equivalent rational expression with this LCD, we multiply by x plus 2 over x plus 2. And now that our denominators are the same, we can write this as one rational expression by subtracting the numerators across while keeping the common denominator. Now we need to simplify the numerator, so distribute the 4x, and then we'll need to multiply these two factors. And then make sure to enclose their product in grouping symbols, because we will eventually have to distribute the negative to each term. Simplify further by combining like terms. Distribute the negative, and then continue to further simplify. And once we're done simplifying the numerator, we want to see if our rational expression is written in simplest form. We would need to factor the trinomial to see if there's a common factor that can be divided out. So we look for two numbers that multiply to negative 10 times 2, or negative 20, and also add to negative 25. However, none of these factors will hold that condition. Therefore, this trinomial is not factorable. And this will just be our final answer.